Awesome. So again, I'll say about the IoT. There was a talk in here that was going to be IoT, but it has been swapped out for this one because I think it was two presenters and they both got sick with the same thing. And they wanted to still do the talk, but I think Jacob, the organizer, said no. If you both get sick with the same thing, probably not a good idea to keep going. So my name's Martin Hinshelwood. I'm going to be doing a talk on the live site culture and site reliability that the Azure DevOps team that Donovan was just talking about are using today. That doesn't mean that's what they're going to be using tomorrow, nor does it mean what they were using yesterday, but it's just what they're doing just now. It's a progression, it's a learning experience for everybody, and they're not by any means doing everything right, as Donovan alluded to. But just a little bit about me. Oh yes, I was defeating the scaling unicorns because scaling is hard. I'm from a little island off the coast of Norway, over there. You probably guessed from the accent. From the traditional dress, you will find that I'm from the smart part of that island, which is up here in the yellow. For those that aren't familiar with this little diagram, the yellow are those that did not vote for Brexit, and the blue are these folks here, who I'm not sure what's going on, to be honest. The hope that I have, at least being a Scotsman, is that we can maybe get off that sinking ship before it goes down, but that's a forlorn hope, I think. But for that reason, I married a Mexican, and I'm halfway to getting my Mexican passport, so that will hopefully work out a little bit better. Donovan talked a lot about how Microsoft had changed, and they saw the writing on the wall they had two massive, expensive failures. One was Windows Vista. I like to pick ones that we're all familiar with. One was Windows Vista, and that was a quality problem. It took them an inordinate amount of time to get that out the door because the technical debt was so high in the product. They fixed the technical debt problem, released Windows 8, and it wasn't what people wanted. So that's two sides of the same coin. You've got a quality problem, and you've got a meeting expectations problem. And the reality is that the world has changed so much that we have to be able to take advantage of business opportunities as they arise. My background is DevOps and Agile. I'm a Scrum trainer with Scrum.org, and I've been a MVP with Microsoft in the Azure DevOps, I guess, TFS back in the day, space for the last 10 years. So we've been working with these technologies for a long time. And I want to cover a few things that are to do with how that team at Microsoft has been able to successfully engage with their customers and successfully deal with LiveSite at scale. You saw some of the numbers that Donovan showed. I have them in here as well. I mean, it's huge numbers, and that's just Microsoft. Outside of Microsoft, it's big as well. But if you can't be bothered listening to the whole thing, I have these are the things that you should be doing. Quality and transparency build customer trust. You need to really engage your customers so that they feel like you're telling them the truth. So that when something's not quite right and you can just say it's not quite right, they're there with you and are willing to accept that for the awesome features you're giving us, we'll give you a little bit of credit for mostly doing the right thing. Telemetry that Donovan talked about, organizing and responding and learning faster, being able to shorten those feedback loops and get changes in and get fixes in as quickly as possible. And obviously automation is key. If you've got people manually doing stuff, you're going to be in a disaster. One of the things that I always talk to teams about that is technical debt is anything manual. If you have manual testing, manual builds, manual deployments, that's technical debt. That's something you need to go fix. But also getting to the root cause, finding out what's actually the problem Donovan said putting a timer in to reboot the server every couple of hours because there's a memory leak doesn't solve the problem. You have to find what the problem is and fix it, because otherwise that's going to keep happening and you're going to keep having outages and keep having problems. But first I want to tell you a little story just to set why is it so important to have your services up? Now, I don't know what services you folks run. Well, I know what some folks are running. But I'd like to tell you a story about a company with nearly $400 million in the bank, well, in assets, that went bankrupt in 45 minutes because of a failed deployment. Has anybody heard this story? No, a couple of people. Yeah, a couple of people have heard this story. It's the Knight Capital Group. So they were quite a big organization, listed on the New York Stock Exchange, but financial services firm. So they're doing stock market trading, they're doing order processing on the stock market. So it's very high money items. They created a kind of new order handling feature. They thought, this is going to be awesome. We'll have this awesome new feature. They actually took quite a long time to build this new feature. It was about between 6 and 12 months to build this new feature because, not shipping very often is a good idea. And they decided to replace a whole bunch of old code. So the old ordering handling system will just replace it with the new one. But, I don't know about you, but for me, quite often, the sign of a good programmer is we're kind of lazy. We want to do the minimum amount of work to solve the problem. But in some cases, that's not the best idea. But because they had 9-year-old code in the system. So the system's been around for a long time. Probably very few of the engineers that worked on that code are still around. But it's always a good idea to reuse stuff. So we've got this feature flag. We don't really know what it does. We think it's not used for anything, so we'll just repurpose that and use it for turning this feature on for us. That sounds awesome. And then we have a manual deployment process. The technician doing the deployment only deployed to 7 of the 8 servers in production. Okay? So I always found it interesting. I used to teach a lot of classes for testers. Is there any testers here? Any testers? No. I used to teach for manual testers using Microsoft's tools. And I would build labs. And if you've ever followed a lab, it's got a bunch of steps, and you have to follow the steps. And if you miss something, it's not going to work for you. And I thought, surely testers could follow a set of steps. But no. They would miss stuff, because we miss stuff. You put 40 things in a list, you're going to miss something. Deploying software is much harder than just going through a test script or following a lab in a workshop that at least is supposed to work. And he missed it out. So they went live. What do you think happened? It didn't work. They started losing nearly $200,000 a minute. Because, high volume trades, that's going to go wrong. And they tried to fix it, but they really couldn't figure out where the problem was. Because the technician's going to be adamant that I followed the scripts. It's not my fault. It must be the software's fault. And the engineers are looking at the software going, well, our stuff looks okay. It must be the engineer's fault. But they ended the day losing $460 million and went under bankruptcy protection. What would be the impact of your software being down for your organization? I've had a customer with a massive product that's deployed on desktops across the world that has a very expensive license point, about $50,000 a license, I think. And they had part of their software that was using something in Windows that a long time ago, that was the only way to do this thing in Windows. But Microsoft saw it as a security flaw, and recently they fixed it. So what happened to the software? It bombed out, it crashed, it blue screened. On all customers' machines. How are you going to find that problem? Some weird hack in Windows that somebody used somewhere. How are you going to figure that out? They actually rolled back the Windows release while they figured it out. Microsoft helped with that because they're a big customer. But what's the cost to you? How much will it cost if your software's down? And for how long can it be down? How long is it going to take you to fix it? We know a lot about what happened to the Knight Capital Group because we can go look at their SEC filing for bankruptcy. And it was a deployment. The technician did not have anybody monitoring them, so there was no backup, nobody with the second jack at the back of the car in case something went wrong. And it just went badly. So what are you going to do? If we want to get better at doing things, we have to practice. I have a thing I've heard a few times. What do martial artists and musicians have in common? They practice. Why don't we? A lot of engineers don't practice their craft. We don't practice deployments. We don't keep running it. I worked at Merrill Lynch, and we used to practice failing data centers, fail out the whole data center, and they used to do it once every 2 years, and it always went wrong. Always went wrong, but they would still only do it once every 2 years, and it would just always go wrong. Usually it was Active Directory was the problem, because failing over that's a bit of a nightmare. So Microsoft created a bunch of tools that Donovan talked about. I'm not going to go into the individual tools. I just wanted to link back to his presentation. What we're talking about is the team that builds this set of tools, and that tool has to support heavy load. Not only are there the folks at Microsoft doing these kind of numbers of deployments, these kind of numbers of commits and change requests and pull requests and work item tracking, there's all the people outside of Microsoft doing it as well. So it has to be able to support at load. Something Donovan didn't say was that Microsoft don't put all of their own stuff in Ring 0. Like the Azure DevOps team is in Ring 0 because if you're writing the code, you want to find out that you've broken people quickly. But the Windows team is in Ring 5. They're the last to get the changes because that's a big problem if you take out the Windows team, which has 4,500 software engineers working on it. Yeah? So they're dog-fooding, but also they have the same risks that the rest of us do as well, and they're not crazy. But they do things at crazy scale. So one thing you need to try and create inside your organization if you're running a service at scale is that live site culture that's similar to what they have at Azure DevOps. This is the things that they do at Azure DevOps, the things they focus on. They're going to make decisions based on data. They're not going to make decisions based on gut feel. They have data points for everything. I'm going to talk about what the data is that they have, how they collect it, what that looks like, and how they surface it to developers. I have a very small demo where I can show you how they surface it to the engineers that are looking at the page. Who's a user of Azure DevOps here? Anybody? Okay. So you can go find this stuff. There's a little magic flag you can go set that will let you see all of the engineering front-end tools that the Azure DevOps team use. So it's pretty cool. I wouldn't have it on all the time because it means the page loads slower, but you can have a look at it. But you need to focus on live site first. It sounds like it's obvious, but you'd be surprised the number of customers that I work with where production is down and there's still people writing new code. There's still people writing new code and expecting to ship it to production, but production's down. Who's fixing production? Well, whoever we can randomly pull off. Oh, they're not busy. Let's get them doing it. And that's not the way to do it. You need to focus on live site first. You need to feel the pain. Like Donovan said, they have a special machine that the person who's on call has that is the only way to access the Azure DevOps instances. And if you're a software engineer and you're on call, you're getting woken up. But you've got to remember, you're not necessarily going to fix the problem. You just have to figure out who else do I need to wake up that I need to fix this problem. So there might be 20, 30, 40, 50 people woken up in order to go fix this problem from different teams around the world as they figure that out. You want to find out before your customers that your system's down. Now, Azure DevOps is very mature at that now, but back 8 years ago when they moved Azure DevOps to the cloud, and what was it, Visual Studio Online? Was it? No, TFS Services, it was called first. If you're not using it, it has an identity crisis and they change the name every couple of weeks. But the Buck Hodges created his Twitter account because he found that people would tweet at him before his own folks knew that the servers were down. Before internally they knew that the service was out, a developer would send an angry tweet to him saying that they can't access the service. That's not what you want. You don't want your customers finding out first and then they tell you and now you know the service is down and you go look and go, oh yes, it is. That's not where you want to be. At one point they had a part of their deployment rollout that Donovan said takes about 10 days to roll out across all the instances. If you're using the service, they have a feature inside the deployment tool that allows you to run a check for whatever you want before you continue with the deployment. And you can have it run every 15 minutes, check some stuff, and then when the flag turns true, then you carry on with the deployment. And one of the engineers wrote a Twitter sentiment bot. So they can deploy to Brazil and then monitor Brazilian Twitter for people complaining about the service and stop the rollout if that happens. Because it just could be just lower performance. It could be you've changed something small and it has a big impact on users, but it's a small impact on the service. They don't need to do that now because they have better telemetry, so they find out first what the problem is. And we talked about automation. You need to have configuration as code. You can't be deploying environments yourself because mistakes are going to be made there as well. You need to be deploying from a definition of what your environment should be and always deploying from that. And you really need to be open to learn from your mistakes. Like Donovan said, don't punish folks for the numbers. Yes, we're down, that's bad, but we need to figure out what the problem is and fix it, not fire the person that caused the problem because they're the one least likely to make that problem again. So firing is probably not the best idea. So this is the culture that they've created inside of that team to be able to support that service. And there's a number of things that they've come up with that works really well for them. I'm not going to say it's going to work for you. You need to try it and see what works for you that allow them to do that. So they have a live site process, a system that allows them to get the alerts out to the right people. Donovan talked about, do you remember what he called the magic laptop that is the only one? He gave it a special name. I can't remember. Every time I think about it, I think of that case that goes with the president, the football. You know, the one that has the launch codes. It's kind of like that type of thing, a secure laptop. But it could start with a customer support call. It could start with a customer support call. One customer somewhere has a problem. Maybe their automated builds are not firing properly. And from a telemetry perspective, things look okay, but the customers notice something, so they raise a support call. It could be somebody on your team comes running down the corridor and says, oh my God, there's something wrong. Yeah, that could trigger going into this process. It could be social media. Like I mentioned, you definitely want to be monitoring social media if you have a public product because things do slip through the gaps and you need to be making sure that that's there. But also monitoring, alerting on your system to know what a negative output looks like. It's important to have monitoring on all of your services. The teams that build those features should be responsible for deciding what that monitoring is, because if you're going to be woken up by the monitoring at 3 o'clock in the morning, you better have control of what that monitoring means. Yeah? But also, who's best placed to decide what bad looks like? The people that are writing the code are best placed to decide what bad looks like. And they should own what bad looks like to their customers, because if you're focusing on delivering value rather than just delivering features, there's no value in something your customers can't use. So you need to understand how your customers interact with your product and build metrics and measures around that, and then collect that telemetry and know what's your thresholds for triggering alerts. And that's part of this system, and I'll talk about the different technologies they use around that, but they're the things that you would be able to use in App Insights in Azure that are out of the box anyway, plus a few extra things. And then they've built their own custom auto router that takes that information from the alert. Well, what team is it that added that alert? Who owns that alert? Well, now we know who to go wake up. Yeah, at least initially. The code that's messing up, that's who gets woken up, or at least the person on call for that team. So if it's one of your colleagues' code, that's probably the first person you go wake up next. Yeah? And they have call rules and triage, so if that person's not available, somebody else has to get woken up. The things you would expect. And they end up with these two types of people that are part of their system. You have feature lifecycle engineers. That's their role inside of the team. So these are team members who are called feature lifecycle engineers. And then you have an SRE team, which is a separate, smaller team that runs as a Scrum team that just runs as an SRE team. They're a completely distributed team because 24-hour support. I know they have at least one person in Australia. They have at least somebody in Europe. They have somebody in the US. And I think there's 5 or 6 people on that team. I know a few of them. It's a small team because it's you don't need a lot of people to diagnose and understand those problems. But that's a separate team. So it's not, they don't work as engineers on the actual teams, but they also have feature lifecycle engineers, and they do work as engineers on the teams. They get together and they do an impact assessment and decide how they're going to deal with this problem. Is that something they're going to create a bridge and wake everybody up? Because that's managers, everybody gets woken up for that one. Or is it something that we can quickly mitigate? Maybe we just push a small fix and that engineer can figure it out and push a small fix. It's a simple thing. So they do that. And have you ever, anybody here tried to raise a support ticket on the Azure DevOps site? Because I have. They give you 2 options. Option 1, well, unless you have an enterprise agreement, they might give you more options. But option 1 for us as Joe Blogs, just using the service, is business hours support. So you raise a ticket, it's free, best effort, business hours support. So if it's the team in Hyderabad, it will be Hyderabad hours when they go pick up that ticket. Okay? The other option says, no, holy crap, I need support now. But when you push that button, it says, please enter your credit card number, and we will put a hold on $600. And if it's not our problem, we're going to charge you $600. But if you're sure it's our problem, we're going to refund you if it's our problem. And that's to stop you because they're going to go get an engineer out of bed. Anybody here been on call? I've been on call. Doesn't it suck when the business just have that phone number for the on-call phone and somebody wakes you up and you go look and you're like, this could be dealt with tomorrow, but I've been woken up. You don't want that situation because people will resent that on-call phone because it's false alerts. Yeah? So you need to make sure that it's the right thing you're getting woken up for. Apparently $600 is that threshold. That if somebody's willing to put up $600 to fix their problem, then it's probably a big enough problem that can't wait till tomorrow. That's why they do that. I think if you have enterprise agreements, you get extra capabilities. Some things have gone down in the past. Microsoft had there's been a couple. Visual Studio Online's been down. Azure DevOps has been down in production a number of times. If you've been a user for a long time, you might have been through a number of outages. The lightning strike in the data center was definitely one. That was everybody was out for, because Azure Active Directory was down, so pretty much everything was toast. But there have been other outages. I remember one of the early outages was the SSL certificate expiry. Does anybody remember that? Azure was taken out because somebody forgot to renew an SSL certificate. Yep. And then 12 months later, yep, same thing happened again. I'm pretty sure somebody was not happy about that one. But it's not like it's Microsoft's problem. Amazon's been down. Google's been down. Yeah, Netflix used to be just on Amazon. And then there was an outage. So now they're not just on Amazon, they're on all of the platforms. Because we have that thought in our head that, well, it's the cloud. The cloud can't go down, but it kind of can. Everybody has weird problems, and it's still somebody else's code that we're running on, and other people make mistakes, and we just have to deal with that. So LiveSight's important because when you add good features, you also need service resilience. Because if you add a lot of nice features, people are going to start using them. You're changing things in production. If you don't have that resilience built in, then you're not going to have happy customers. You're going to have unhappy customers that don't like your service. I use a number of services that are not up as much as I would like, and it is a frustrating experience. I remember getting an email from the Azure, when it was, at what point was it? It was Visual Studio Online. And I got an email, because I had an account on Visual Studio Online, and I got an email from the team that said, we're really sorry, but we're going to be taking your service down while we do a database update. We think it will be down for about 3 or 4 seconds at midnight. And I'm kind of like, man, that could be a glitch in my internet connection. And you refresh and everything's working. You would never notice that, but they felt the need to email everybody who had an account and figure that out. So how do we build trust with our customers? Or how do they build trust with our customers? Donovan alluded to it. Incident awareness. Make sure your customers know when there's a problem. Not just if the customer's not screaming, maybe they don't know yet. Maybe we can fix it before they find out. No, make sure they all know. If you were on, Donovan pulled up a list. I don't know if you saw it. It was kind of that list on the right-hand side that had grayed out names. I think they actually chopped the names off, but it had locations and size of the customer. Some of those customers are in Norway. Those are the top customers in Azure DevOps outside of Microsoft's internal stuff. So not Windows, which is just the biggest pile of craziness you've ever seen, but other customers. They will phone those customers to make sure they know that there's a service outage and what can we do to help. Yeah, but if you're like me, I just have a small service where it's just me using Azure DevOps. I'm going to get an email. I'm going to have access to a blog post. I'm going to see what's going on. But I'm also going to know why something went wrong. I'm going to know what the problem was, because they're going to publish a blog post that tells me exactly what went wrong, why it went wrong, what they broke or messed up or deployed in order for that to go wrong, and how they're going to make changes to the system in order to fix that, and what's the rough timeline we think we're going to do on that. All the way down to the actual data and metrics that they used to do their root cause analysis and identify the problem. You can go look up any of these emails. They're all crazy detailed emails, blog posts, but it allows you to see the depth of data that they have to make those decisions to figure out those problems. And most engineers, most systems customers that I work with don't have anywhere near the level of data that they have, but some of them have the same size of systems. But they couldn't tell you what the problem was. That, oh, the server's getting slow, let's reboot it. That'll fix the problem. Yeah, it fixes the problem for a couple of weeks, and then it starts happening again. And nobody bothers going to find out because it's too hard to figure out because they don't have data. So they collect an awful lot of data. And just general transparency, talking to people. So they have this kind of mission control tool that they've built. It's just an internal tool. It used to be in a spreadsheet. And then they would update this spreadsheet and some macros would kick off and go update the various systems. So they have a status update page. The one Donovan said went down because it was only in one region. They have the blog post, which is updated, which is also in the same region, so it went down too. That was scary, but and also emails. Microsoft internal emails out to customers and key stakeholders get an email right away to say that there's a problem. But they used to do it in Excel, which gives them a 45-minute turnaround for how quickly people know about the problem. And they found that was not good enough, so they've gone all the way down to 15 minutes. Within 15 minutes of an incident happening, all of these things have been updated. I think today, that's from last year. I'm pretty sure today they've got a much faster system. When they rebuilt it to have distribution, they made it faster again, and there's just a simple website that you as an engineer or the person managing that incident can go fill out a form, hit a submit button, and all of that stuff gets updated to say there's a problem, we're looking into it. So it's really important to get your customers into the loop as quickly as possible. What about telemetry? I did say I was going to tell you about the telemetry that they had. It's a lot of telemetry. I don't know what 7 terabytes per day of telemetry looks like. I'm sure you don't either, but we can imagine it's a lot of telemetry. But the data is from all sorts of different aspects of the system, not just hardware and infrastructure, but also how the application is performing. For example, if you were the team responsible for new acquisitions, i.e. that first experience when you go to Azure DevOps and you create a team project. What if it's taking a long time to create team projects? And your customer's sitting there waiting for that team project to be created. You've got a problem. So if you measure, as the team owning that, we're going to measure how long it takes. We know what we would like it to be, or the scope within which we're happy. As soon as it crosses that boundary, we should get an alert, we should know, and we should be able to go and investigate it. It might be nothing still, but we need to figure out, based on those bounds, how we make sure it's a good thing to do. So we want to continuously improve those things, do our root cause analysis, 5 whys. Keep asking why till you find out exactly why the problem has occurred, and be able to figure out then how to repair it and get stuff on your backlog. Make sure you don't just do a root cause analysis and then do nothing about it. You need to get stuff onto your backlog and be able to make changes in the system to be able to make sure that doesn't happen again. So they have a telemetry pipeline. They use different systems. You've probably used them as well. They've got the Azure DevOps, not Azure DevOps, my brain died there. They have App Insights, where they feed a lot of data. They have the Azure alerting and monitoring system, where they pull a lot of data because all of their stuff is running on Azure services, not as VMs, but as services. They do have some VMs. But they've got the compute, and then they have to decide whether it's they call it hot, warm, and cold metric. Cold metrics are stuff that comes off your data warehouse that you really, there's a lag for getting the data from. We get immediate notification, like from the metric system or monitors. You can have immediate alerts go out and triggers happen. To cold, which is we've fed all of the 7 terabytes of data that we get per day into a data lake, and we have tools that are checking that data for trends and analyzing the bigger picture, which maybe takes a little bit longer to figure out that you've got a problem. Does that make sense? Yeah. So that's Power BI dashboards, and all of the teams are responsible full stack for their analytics as well as for their features. So they get that through Azure Diagnostics, App Insights, and Azure Data Lake is what they're using just now. So they've got that lovely 7 terabytes per day. I'm pretty sure, I was told that's actually just Visual Studio, not Azure DevOps, but Donovan seemed to think it was Azure DevOps, so maybe I'm wrong. He's more likely to be right than me. But they've got SLAs, alerts, dashboards, all of the things that you would expect. KPIs, what should we expect these measures to be? And then they have the usual things you would expect. we're looking at the data to figure out how can we detect that there's a problem before customers do. But you need enough data for that. They also have an interesting thing that as an engineer, I've tried to do before, and I think I failed every time I tried to achieve this, but it's to understand the call through the system. You have a front end, you maybe have a mid-tier, you have a database. Can you trace that user's call through your entire system? Do you understand when that user rendered that web page, what services were called, what database calls were made by those services, how long did they took? Can you pull that data together, and can you pull it together easily and quickly? Anybody in that category that they can do that? Oh, there's a couple of people putting their hands up. It's hard though. I mean, App Insights solves a lot of those problems for sure, and I have App Insights in some of my tools too. But even going all the way into SQL Server, not just I made a call to SQL Server, but going into the SQL Server, what stored procedures were called, what were the SQL calls that were made, how long did they take, gathering all of that data together is you need to do some extra work to make that happen. App Insights is definitely a good start. Stick that on there and you collect a lot of data. But being able to see that correlation across all the bounds of the system, even if you called out to not a third-party service, but a second-party service. They have a number of services as part of the system to be able to identify that and all of the dependencies, which you get some of that through App Insights for free, but actually seeing into the database. There's too many things. So Donovan talked about the service health. And being able to see those trends. Trends are more important sometimes than individual pieces of data. Are things getting better or are they getting worse? It tends to be more important. But they're able to look and see availability per instance, downtime in minutes per hour, so they can get a look at, there's obviously something happened there, but is it a big enough problem that we need to do something about, or is it one of those we've got lots of things talking to each other and you're occasionally going to get glitches? My understanding is they have to pick up the phone to the Azure SQL team quite a lot to figure out what the problem is, because they're heavily dependent on SQL Server, especially for, if anybody's still on TFVC. Anybody still on TFVC? No? Nobody's putting their hands up for nobody wants to. Yes, I saw you there, Richard. You put your hand up. If you're still on TFVC, TFVC does almost all of its processing in stored procedures. So every time you check in, check out, it has to do a diff between versions. That's all happening at the SQL Server level, which is hugely expensive and usually requires a call to the SQL Server team when something's not working properly, because they're doing things that you wouldn't normally do on a cloud service, because that's just the way that system was originally built. And they're not going to go change it because everybody's on Git now, so that's pretty good. Everybody knows Windows is moved over to Git, don't they? Everybody here, everybody nodding? 350 gig repo. That must be awesome fun. It's not, but there we go. You need to extend that visibility into the dependencies that I mentioned, being able to see exactly how long your stored procedures took to call, and you see the red, amber, green. I want to know whether that is an exceptionally long time for that call to that stored procedure. So the folks writing the code are the ones that need to understand that, because they need to set these measures in place. When does that go amber? When does that go red? What happens when it goes red? What alerts are called? What is the things that we need to do, the alerts that we need to have? You'll get a copy of the slides. I have a QR code at the end, so you can get a copy right away, and then I'll tweet it out. But there's lots of data that you can go see the correlation of everything together. And they actually have a little activity log schema. So from a user, both tenant, which is the Azure tenant, account, which is now called organization in Azure DevOps, and user. So from all of those aspects, they can slice the data. So they want to see what's going on for that tenant. So you have a tenant that has 20 accounts. You can see what's going across the board for all of that data. You have a particular account that you think is having a problem. You can slice the data by that account. Or maybe there's one particular user that's having a problem. Well, let's look at the data from the perspective of that user. So you might find that there's one user that's got a problem and everybody else is fine, and there's some weird thing going on with their credentials. And in the grand scheme of things, I don't know about you, but you have an impact analysis and the bug report, and there's one user, yeah, whatever, we don't really care, there's only one user affected. But from their perspective, that one person is going to tell 10 people the service sucks. Or if it's Donovan, he's going to tweet it, and that's 15,000 people now, he's told. Yeah, and it's the same for most of us. So they're able to slice that data from whose perspective. The different resources, so service, region, skilled unit, roles within the different instances and services that they have. The context of the request, so which application layer are the problems happening in, and all the things you would expect, all the way down, if I go all the way down, there we go, to SQL performance, Azure Active Directory, all the dependencies that you have, storage, all of the physical data is, the binaries are stored on Azure Storage. So now you've got SQL dependencies, storage dependencies, making sure everything's working together. And if you see the metrics, time to first byte, execution time, can we identify whether the SQL storage is not responding quickly enough, in which case maybe we need to go talk to that team and figure out what the problem is. So it's really powerful to be able to have that data and have access to that level to make those decisions. And yes, so let me see if I can, if I do that, oh, nope. I can do that. So you have this little URL here, diagnostics. And I'm going to copy it so I don't type it wrong. But if I go to, I'm just going to go to my account, because then I'm not showing somebody else's. Oh, it's dev. So if you go to any account, this will work for you as well. And you put diagnostics on the end, you'll get to a lovely page, because it's not really meant to be, it's not really a user-friendly page. You will not be able to link directly to this page. And I can go and turn on diagnostics. I could, for example, turn off minification, because you know that thing where you're trying to debug the web interface because it's not aligned right, and you're trying to look at unminify. Yep. Why not just build in a tool to your application that does it for you? And you can turn off the CDN, all of those things. So if I've turned that, and I now go back to the home page, it should, unless I didn't do that right. I maybe didn't do that right. Let me go into a, yep, for some reason that didn't work. Let me try that again. Let me do that. Now I've got it. If you look at the bottom of the screen, you'll see that there's a little diagnostics bar, and you will also see it has a little smiley face. That means this page has met that team's OKR. So the OKR for response time of that page, so the whole page, they got a smiley face because it was, what, 100 and, I can't see that from there. It was pretty fast. There we go. Let me pop that up. Now I can see exactly what was called during this page request. So there's the pre-page request, so the DNS call, page requests, and if I go down, I should be able to find one that took a little bit longer and go all the way, well, not that one. I'm trying to find one that has a SQL Server call in it. Nope. I can't find one that has a SQL Server call in it. But you can go all the way down to the individual SQL Server calls and see how long they took, how long till first render. Because you can see there the scripts, there's 59 scripts, the Ajax, 13 Ajax requests, and 13 data providers in there. And you'll be able to go in and see all of that information. And there's actually extra diagnostics if you want them. If you were the developer, this might be pretty cool. You can see a graph of the dependencies that are loaded while the page is loaded, so you can go see, is there extra stuff coming in that I maybe don't want coming in? That might be where my performance problem is. Somebody had fun building this, I am sure. So you can see the diagnostics, and then you can see just here's all of the scripts that were loaded and the relationships between all of the scripts. Again, somebody had fun building some of these things. So you can very easily turn that on and off. So I can just go, turn off the perf bar, refresh my page. So if I'm a developer on Azure DevOps, I don't necessarily want to go out to another tool to go figure out that the change I just made my page take longer to load. I can see it right there on the screen. I can go make a change in the system, deploy it to my environment, and then very quickly see, did I make that better or worse? Yeah, so it gives you that data right away. An easy way for the software engineers to spelunk that very quickly and figure out that they've got a problem. So feel free to turn it on and have a look around and see all the stuff you can find. You can go all the way down to every individual SQL call and how long it took and how much data came back and the megabyte, just everything. To give you that knowledge as a software engineer that you need to go figure out what the problem is. Why is this taking too long? Which is really powerful. So it allows you to then focus heavily. That's what that smiley face is all about. How long to first interactivity? How long is it going to take for users to be able to interact with that page? Because the shorter you get that level of interactivity, the better it is for the customers. So you got to get that model of how you figure out that you've got a problem. You can do synthetic tests, outside-in synthetic tests, but they only give you a limited picture because you have to build test scenarios, what it is that you're testing. Brian Harry has my favorite comment that he had, which was, there's no place like production. No matter how much figuring out you do for how do we simulate the real world is much scarier and nastier than you can possibly figure out. So even just the health of individual commands within your system, are things operating like you would expect, and what does bad look like? And even just users are experiencing slowdowns. If individual users are experiencing slowdowns, they're going to complain. How do you then scale it out? Because generally we look at aggregates, but if you've got 6 million people using your service and 300 people have a problem, you definitely want to deal with that. It doesn't matter that it's only 300 users. That's a very small percentage, but they still matter. So they talk about our customers are a bag of sand. No, they're not a bag of sand. You're going to have things in there that are a problem, and how do you identify whether things are a problem? So they have a bunch of metrics that look for, are there customers that are not having the experience that the majority of customers are having? So they can single out individual customers that have a problem and go dive in and figure out what that is. So they have all of that data and telemetry access to them. And yes, it is the engineering team's responsibility to do this, manage this, monitor this. You build it, you deploy it, you run it. They're looking at this data. So impacted users versus active users, what's your threshold for doing something about it and figuring that out? One thing that they found very early on was as they started adding alerts, they got too many alerts going off. So then if too many alerts go off, the incident detection rate goes down because you can't be bothered looking at those alerts because you then set up a mail rule to shove it in a folder. Yeah? So it becomes completely useless. So at a certain point in time there, you can see they did a bunch of exercises around, let's have less alerts going off. Let's only have important alerts going off. And they pulled that down fairly quickly. And then once they'd got it down, they started seeing more incidents being detected. It's just human nature. If there's too much going on, then you can't figure out what it is. And then they started introducing customer impact alerts. Are customers being impacted? Rather than just focusing on, well, this stored procedure was taking a bit longer. Well, the stored procedure is working fine, but customers are still having a problem. So there's something going on there. So actually looking at that. So that was around telemetry. Responding faster. They've found that, as we know, throwing it over the wall to DevOps is not going to work for you anymore. You need to pool those things together. But it's difficult because we pull those things together and now our engineering team is responsible for production and there's things going on in production all the time. How do you make sure that, I teach a lot of Scrum teams and they're always saying, but we don't have time to pay back the technical debt. The product owner never prioritizes the technical debt, so we never do it. So how do you manage that? How do you create a system with balance so that you're adding new features, but you're also dealing with the technical debt? It can be quite difficult. So the Azure DevOps team came up with this kind of a little bit hybrid idea. They used to have developers, testers, and ops, like Donovan was talking about, but then they pulled those things together, and the developers and testers are just on feature teams. But they also have these live site engineers that are part of the team. That's the old ops folk that are now working on the engineering teams. And that's really split between two stories. Remember I mentioned they had the dedicated team, which was the SREs, the site reliability engineers, that small, nimble support group that works across the organization. They're the SREs, who are a distributed team working in different locations. But the feature team live site engineers are just team members. It's a hat that one or two of your team members in your team wears for that sprint, and that's their job for that sprint. Their job is not adding new features. Their job is dealing with live site. 100% of their time is live site. So you have two people on every team who are allocated, and how many people you allocate will depend on the balance of your product. But for them, two people are allocated every sprint as feature team lifesite engineers, and it rotates. One, so that everybody feels the pain a little bit, so you want to write better code. But also, you figure out what needs to be changed, so maybe you don't build in those technical debt things in the first place, because you have to pay it back. So what they do is they have those folks taking responsibility for many of the things that generally slip through the cracks within an organization, within a team. So they're going to spend the least amount of time working on product contributions, like adding new features. That's not what their role is. If all of those other things in there are done, then they might work on adding new features. But there's things, resiliency engineering, what changes can I make to this system to make it more resilient, to make it more performant, to understand performance better? Can I change the alerts to make them more effective? Can I change the telemetry to make it more effective and more useful? That's their focus rather than features during that sprint. So the problem management, monitoring, service management, and then if there's a live site incident, they are 100% going over to deal with the live site incident. They might have to pull in other people, but that's their role. But also looking at security, operations, and compliance as well. So they're focusing on that. So you're always going to get that stuff done. When they do identify problems, like if there's a live site incident, they're going to do the root cause, identify things that they need to go on the backlog to fix. That's the backlog that feature team lifesite engineer is working from. They're not adding new features. They're working through the backlog of technical debt stuff. Maybe we need to make some architectural changes. One of the things that they did recently was circuit breaker pattern. They found that the profile service, one of the outages, I think it was 2 outages ago, the profile service for Azure DevOps was down and it took out the entire system. Because Azure DevOps couldn't figure out what your friendly name was, it took out the entire service. Because it was just a dependency that was down. So they figured out that was a problem. There's a blog post about it. And added a circuit breaker pattern for all calls into that service. I think about 8 months later, the service got taken out for a few hours because of another service that wasn't 100% needed that was down. So they decided to implement circuit breaker pattern for just everything. But they're fixing that problem permanently, and they've got people in the teams across all of those 50 teams. So if you think there's at least 100 people working on live-site issues, paying back technical debt, dealing with those problems, figuring out what the next thing we can do to preemptively deal with whatever problem might come up. Yeah, so if they have 52 teams, 2 people per team, that's over 100 people dealing with that at any point in time. Yeah. So that's where those 2 people come from in that diagram I showed you earlier. The feature lifesite engineers and the SREs, when there's an incident, a lifesite incident, they get together, make an assessment, and figure out what needs to happen. They get on a bridge. You've heard me mention it a couple of times. I think Donovan mentioned it, a bridge. A bridge is a magical Microsoft term for conference call. You get on a bridge, and those are the folks that need to deal with that. Certain people, they have rules around bridges. Some people are allowed to talk, some people are not. Like managers are not allowed to talk because it's the engineers that have to solve the problem. So you have somebody who owns it, who's the person with the special laptop, that's the person that's on call, and then they bring in whoever they need to figure out how to solve the problem. So they could be pulling people in from the SQL team, from SQL Azure, from storage, from wherever they figure out there's a problem to help diagnose it. So they're just responsible for making sure that they become the incident manager, and they're responsible for making sure all that works. I mentioned it was 2 people on the team. It's a rotating role so that everybody gets a little bit of experience doing it, but it self-organizes into those 2 sub-teams. So the teams figure out who's going to be the lifesite engineer for that particular sprint, and whether they rotate it. That's all up to the team. That's an autonomy piece rather than a defined. You have to have lifesite engineers, but what they're going to be, who they're going to be, and everybody learns a little bit from that. One of the things that they do as well is red-blue exercises, where they hire a team of professional hackers to hack Azure DevOps, and the blue team's got to try and defend. And you know, it's one of those things where invariably the red team usually always wins at some point. But being able to at least identify that the red team are doing something. I remember an exercise where I was using the build server, and the build logo, if you've used the Azure DevOps build server, like the Visual Studio logo goes up, and it came up one time, it was upside down, and we wondered, what's going on with that? There was a couple of tweets of people, and it was because the red team won. They left their trace of, we have been here, and we owned your system, and here's the proof that we managed to get in. And then they take that information, and they go figure out, how did they get in? What did they use? Because usually it's an attack vector that you as an engineer would never think of. And they go educate the engineers across the organization, and there's nothing more humbling than you sitting there and somebody doing a presentation, and you're like, wait a minute, that's my code they're showing. That's my code that a hacker used to get into the system. Okay, maybe I need to code different. How can I code differently so that I don't leave those gaps? So they build security in to their process. Everybody's responsible for security. But the green dudes there, the live site team, are 100% dedicated to dealing with some of the fallout of those things and making changes to the system. The other thing it allows you to do is shield from a Scrum delivering features perspective. You're shielding the rest of the team from those things that are happening on a continuous basis. That BAU, that things that are happening, you're protecting the team. They're focused on delivering new features. These two folks are focused on dealing with any live site, those engineering pieces, make it a little bit more easy to keep going and keep delivering while you're doing that. So the priorities for those live site engineers, ongoing active live site is the most important thing. Past live site incidents, things that have come out of that, changes, tasks, enablers, I don't really like that term, but enablers and technical debt, things that help you do things better. And then third is improvements to monitoring, telemetry, and alerts. I can't imagine a scenario where you would ever be done with that in a 2-week period, which is why there's not a fourth thing on the list that says, yeah, go work on the features, because you would never be done with this. There's always something else to make better in that scenario, which is why they have that dedicated resource making sure that these things get done, because if you don't have that dedicated resource, they just never get done to the level that they need to get done at. So when they're, if you look at the sprint progress, you can see just the live site things popping up as the team is going. Most of the live site things we never hear about because it never takes the whole system down. It might be builds are running slowly or various things. I see it a lot more. I'm an MVP. I have internal email groups with Microsoft, and I see a few more of them where, for this customer, the builds are running a little bit slow. Okay, they go make a change, roll out a fix, and it's fixed on the trains that Donovan was talking about. So we don't get to see most of the things that go wrong because they're not big enough to take out a large enough customer set to make it a problem. I'll talk about automation. I think I only have a couple of minutes, but they started with manually solving the problems and then moved towards automating things. So most of their systems are automated now. When a problem happens, they have automated auto mitigator that goes and resolves the problem from the perspective of end users while also alerting the engineers that there's something they need to go deal with. So that's the effect of, we might need to just reboot the server. Okay, problem's gone, but we're not going to leave it there. We're then going to go and figure out how the problem happened and what we can do to fix it, because you've got so many users in the system to get less problems. So we talked about quality and transparency, getting information out to users. We talked about customer experience and telemetry. Make sure you understand what the customer experience looks like and have the telemetry to back it up. So you find out first that there's a problem. Make sure you look at all of the data and understand what the alerts mean and be able to respond faster. We just talked for a minute or so on automation. Make sure you've got automation for everything. Everything should be automated. There should be nothing manual between engineers committing code and code ending up in production. Doesn't mean there's not an approval process where somebody has to go click an approve button, but there shouldn't be a manual set of steps that somebody runs, and make sure you get to the root cause. Go figure out what the problem is, dive deep into it as much as you can, and figure out what things, actionable commitments can your engineering team make to have those problems not happen again in the future. If you want to dive into some of the extra data around this, there's some really good videos on the Microsoft site talking about the SRE role and how their site reliability engineering works. You can download the presentation. That QR code will give you a copy of the presentation. It'll also be tweeted in about 5 minutes. And there's lots of good data out there. Are there any questions? I know I'm leading into your break time, but any questions? No? Thank you very much. if you wanna get in touch with me, feel free. Lots of different ways to do that. Feel free to tweet at me, Teams, blog, whatever.